All right, welcome to another podcast. In this episode, we're going to be taking a look at a class of models called depreciation models. Appreciation is the process by which money grows or which goods gain value. So appreciate means to grow in value. And the word depreciate means to lose value. Most of the problems we do financially are appreciation problems. They're problems in which an initial investment grows over time because we like to see our money grow. But there are things like cars which depreciate in value, and at least for the first couple of years can depreciate so rapidly that it does mimic exponential growth. And so what I wanted to look at, exponential decay. What I want to look at then is an example of that so you understand how to apply that to our compound interest formulas in order to get the right answer. So the example I have is looking at a car that's depreciating. It originally cost $25,000 and it has a per year depreciation rate of 12% for the first 3 years of its value. And I want to know, if I try to resell that car after 3 years, then how much will that car be worth? In other words, how much am I going to lose in those 3 years? Well, the easiest way to do this is to once again list all the variables that are involved. The principal value is $25,000. The future value is the value, in this case, after 3 years, which we want to know, so we're going to solve for that. The rate is what we have to be really careful about. It's losing 12% per year, so 12%, which in a formula I need to enter as a decimal. So I'm thinking about negative 0.12 as the decimal here. The compounding period is, the rate is 12% per year, and it says nothing about compounding, so I have to assume that the rate applies at the end of each year. And then the time involved for this problem is a total of 3 years. So if I revert to my compound interest formula, then this is what I would be looking at. 25,000, 1 plus the rate, which is negative 0.12, divided by n, which is 1, for 3 years. So I could simply enter that in my calculator, or if I look at this, I get 1 minus 0.12 is 0.88 for 3 years. So what I should think of this as, the car retains 88% of its value. So this is sort of a glass half empty, half full thing. It's losing 12% of its value each year, but that's the same thing as saying it retains 88% of its value each year for the next 3 years. And so it's 88% of the previous year's value. So plugging this into a calculator, what you would wind up with here is $17,036.80. So notice that this is the first case where we've actually had a future value that was smaller than our present value of 25,000, and that's because the rate is negative. This is a decay, and you can see that the common ratio, or the growth rate of the exponential, is 0.88. We look at how that is less than 1, that also implies decay. So everything here implies that we're getting a decrease in the size of this particular problem. Now, oftentimes we won't know what the per year depreciation rate is for a car that we're looking at. So suppose instead I had a similar problem where I had a $25,000 automobile, and I go look up in something like Kelley Blue Book, which lists values for certain vehicles, and suppose the value I found for my car is, its book value is $13,550, and this is after 5 years. So it'll only give it to me in 5 and 10 year increments, let's say. So after 5 years, I know I'm going to be able to resell it for $13,550. And once again, this is a per year rate. Suppose I wanted to solve for the rate. Now, this is the first time that we've tried to do this, to solve for the rate, and it's not an easy thing to do by hand. So I'm not going to really approach this subject by hand. So let me go ahead and bring in my calculator here. So we were using the finance video or finance command in a previous video. So I've got those commands still entered. And for this particular problem, however, the finance command, the principal value is 25,000. The future value is 13,550. The amount of payment is 0. There's no payment here. The interest rate per period, I don't know the interest rate at all. It's just X. And the total number of periods is 1 a year for 5 years. So there's going to be 5 total periods here. And if I calculate, as it should, it's giving me a negative value. Now remember, the values that come out of here are interest rates per period. So it's giving me a value of a negative 11.53. So if I take this back to the board here, the rate that it solved for is a negative 11.53. Remember, the values in the finance command are percentages. So it's telling me that a yearly, so the word I use here has to match the term there. So the rate that comes out of the calculator, if this had been monthly, then that 11% would have been a monthly rate. But in this case, the problem's yearly, so that's a yearly rate. It's a yearly depreciation rate of 11.53%. So slightly lower rate than the rate in the problem on the left. But by hand, this is a difficult thing to do, solving for the rates, because you have to take the logarithms of both sides and get at the R value specifically, and sometimes that can be a little bit difficult. So for problems that ask you to solve for the interest rates, like this one, you probably want to handle those in the calculator exclusively. The goal for this entire video, though, is just to introduce you to the concept that rates can be negative, and when the rates are negative, it's a depreciation that's occurring which correlates or which corresponds to a decay exponential model. All right, thank you for watching.